Okay, welcome to mini lecture 8. This is going to be a little bit longer. I'm going to try to keep it to a minimum, but we have to understand some key concepts related to maps and geographic visualization. So, again, for the exam, the quiz, here are the terms you're going to need to know. Map, first of all, that's an obvious kind of term for geography, but when we say map, what we mean is a two-dimensional representation of Earth's surface in some aspect of it. Scale. Scale, we always mean the relationship between what we see on the map and the actual size or distance on the map. So real world to map is scale, and that can change. Now distortion is what happens on a map because we're flattening the Earth out. When we take a round spherical object and try to flatten it out, there has to be either tearing or distortion, and actually typically both. One of the things you can always do at home, try to take an orange peel and flatten it out perfectly, and you're going to see that you have to tear it or stretch it or do something with it. Okay, so most important thing to know about maps when we look at maps or any type of computer visualization, two issues. What you want to know is what's being shown, that's often in the legend, and then what's the scale of the map. The reason I often want to look at those two things is that scale forces things to be lost. In other words, at a map that shows the entire Earth can't possibly show all the detail. So as the map shows more and more area, more and more detail is lost. More things have to be generalized. The other thing that you want to look at is in the legend, what's being lumped together? In other words, what are the classes or categories of data that get pushed together in order to make the legend work? So I'm going to give you a couple examples of that. But again, when we look at a map, there are many parts to a map that I'm not going to get into here. You can take an advanced course in cartography. But always think about what's the scale of the map and what is the legend. In other words, what is the symbols on the map and what are they doing and what are they trying to say? Okay, now let's take an example map here. I'm going to show you a couple of pieces on here. So this is a map that showed up in the New York Times, I believe is where this one came from. And what we see here are deaths of migrants, undocumented migrants crossing the U.S.-Mexican border between October 1999 and March 2012, and then also where water stations are. So now there's the legend. What this is trying to show us is two things. So there's two phenomena shown in the legend. One are these orange or red dots, and one are the blue dots. Each one of these, each dot, represents a migrant death, okay? And then we have water stations, shows where they are. You notice they're trying to, I think, show these large gaps in that. The other thing that's on this, though, here is the scale. So it shows that this distance is 50 miles. So what we can see then, again, what the map is trying to say is how far some of these deaths are from watering stations. Now the other way that this map shows scale is it takes and says this box area is occurring roughly right here. So it has a way of showing that. Now there's a couple things that are obviously missing on this map. Because of the scale, some of the information is lost. We don't see the topography of the landscape. We can't see any of the roads. Many things have been taken out. The other thing that we may not see very accurately on here, you'll notice all of these dots come together, and so there's a little bit of a problem of generalization here. We really can't see how dense all of these dots are. We have to kind of take on faith that this is the area where the majority of this is concentrated, because it's hard to read how many dots are there. Okay, now let's look at a different type of legend, and I want you to think about a little bit again about this map. So this is an unauthorized migrant population by state, 2008. If you'll notice the legend, again, here's our legend, and I always want you to think about what is being lumped together. In the case of this legend, all of the states that are in the lightest here have less than 40,000 migrants. Well, we don't know whether that means that that is 4,000, 400, or 39,995. We don't know what these states actually have as their values. All the states here and here have that same low value. In the same way, we really don't know somewhere between 900,000 and 2.7 million are in each one of these states, but again, we don't know which one is highest nor which one is lowest. So we're lumping together some pretty big ranges of data here. And it's always important to understand that. Okay, now I want to use a kind of a scale here to just very quickly, again, show you how this works. This is a map showing 1 inch to 1,000 miles. You'll notice you can see the United States, but in fact we've lost the state borders and some very generalizations in terms of our rivers. If I zoom in to 1 inch equals 100 miles, and we begin to look at where you are right now, you can notice that you're now seeing the lake shores, many more of the rivers, and a great deal more of the topography. We change our scale, we begin to see more detail, but we see less of the earth. And that's always the trade-off. More detail, less area. Okay, now we're going to zoom in even further. 1 inch equals a mile. Now we can see actually the burrow of slippery rock, and in fact quite a bit of the topography, the finer detail in terms of the stream channels, and in fact many of the roads. 1 inch equals 300 feet. You can even see the sidewalks. So again, scale, the bigger the area, the less detail. The less or smaller area, the greater detail. Always a trade-off. Okay, now let's look at that issue of distortion, the last of our concepts. When we map, when we take three-dimensional object and push it into 2D, what we have to do is in some way distort the surface. We have to stretch it in one way or the other. Now what you see here are two different types of what we call our map projections. That is the way of turning 3D into 2D. One of these is a Peterson style projection and the other is what's called a Mercator. And what you'll notice is that the black outlines, this is what's a classic Mercator, the shapes look really quite right. It makes sense to you. But there's an incredible distortion of area. In contrast, when we look at the green part of the map, it's a different projection. This is one projection laid over the other. Shapes get really funny. You look at Greenland here and it's hard to even see what it is, but its area is more accurate. So when we do distortions, when we look at map projections, oftentimes there's a trade-off between the shape of something and its area. If we maintain the area accurately, well, we lose shape. If we maintain the shape, we tend to exaggerate or underestimate area. Okay, that's it for this lecture. Again, remember, make sure you understand the term scale, understand the term legend, why they matter on a map, and then look at the issue of distortion and map projections. These are also discussed in your textbook. Make sure you have those terms for the quiz. That's it.